Hello and welcome back, geometry students. It is our last video on rotations, last video for this week. So today we're going to look at rotations and coordinate plane. How does it apply to when we are working on a graph where we actually have physical spots that we can kind of count? We should already be pretty good with this notation, I'm hoping, that the rotation is capital R. This first point is the point of rotation, or what we're rotating around. The magnitude tells us those two pieces, tells us the direction, and it tells us how many degrees. This is the pre-image. This is the thing that we're moving. And then this is our image, that final spot. And so today we're really learning about rotating around this coordinate plane. And we need to know a little bit about finding slope and some other opposite reciprocal type of information. Now, you're going to see a lot today, a word that we call origin. And that relates to the coordinate plane, origin. See if you can't, in our puzzle question here, identify where the origin is on a coordinate plane. All right. Hopefully you were able to identify the origin as the point 0, 0, or it's this point right here where the x and y axis intersect. It is that point 0, 0. The origin. It's where we base everything we do on a graph off of, the origin or the starting point. And so a lot of today what we're going to be doing is using the origin as our rotation point. So let's look at an example. Let's see if we can't figure out the notation rule that will help us identify this rotation down here. Okay, the rotation rule. So basically, they're taking, let's get a different color, Mr. G. They're taking this E, and they're moving the E to there. They took this R, and they moved this R to down there. And it looks like we're using this origin as our rotating point, right? Or Q went from this axis up to that axis. That might be the best one for us to use. So we've got a rotation. We're using the origin as our center point of rotation. So we're going to write the word origin. You could also write, I guess, the point 0, 0, but we're going to use the word origin. We're going to figure out the degree in just 1 second. The original shape, let's just name it R, E, Q, N. If I go around that shape in that order, R, E, Q, N. And that would give us the image R prime, E prime, Q prime, N prime. All right, so now we got to figure out what degrees, how many degrees did it actually rotate. So first of all, we are going clockwise. All of these points are moving this way. So is clockwise positive or is clockwise negative? It is negative. So we're moving a negative degree. Now you can see there's 2 points on here that really help us. E and Q. They move from one axis to the other axis. Boom to there, Q to Q prime. If we're moving just one axis from one x-axis to the y-axis, that's actually 90 degrees. 90. Okay, so there is our notation. Now, let me try and explain to you where these degrees come from. All right. What we learned before, right? We should know that the x and y intercepts, the x-axis and the y-axis are perpendicular to each other. So no matter what, they're always going to create a right angle. It's the only time we don't use this symbol because it's kind of there in the graph. Okay. The other aspect that we know is that if this is a 90, so is this one across from it. These two together have to total 180, so that's 90. That means this. So all of these are like 90 degrees. Each quadrant in the graph is 90, 90, 90, 90, right? Making a full circle all the way around the graph. If I started and went all the way around, I would get 360. There's that full circle. So as we move from one quadrant to the next quadrant, it's only going to be 90 degrees. But if I move from one quadrant to 2 quadrants away, so here down to here, then it's 180 degrees. So we can kind of use the quadrants to help us figure out where and what the magnitude might be. So let's look at another one where we draw this now. We're going to try and draw the image B prime, S prime, L prime according to this notation, right? We're going to go around the origin 90 degrees. If it's positive 90, that means we have to go this way, okay? We have to go counterclockwise. And we need to move BSL that way. So again, the easier ones to start with are the ones that are on the axis. So L is 1, 2, 3, 4, 5 units away from the origin. If I'm going to go 90 degrees, right, 90, I got to put L prime right up here, 5 units away. That'll be our L prime. And now we can kind of use the knowledge that we have of slope, so to speak. So if I look at B, B is going to be 1, 2, 3, 4, 5, comma 1, right? 1/5 away. And so what we end up doing is creating the perpendicular. Instead of it being 5 units up and down, it's going to be 5 units to the left and 1 unit down. So that B prime ends up being that location. S, 1, 2, 3 units this way and 2 units up. So 3 units, 2 units up, which means if I do it backwards, 1, 2, 3 and 1, 2 units, right? It should end up on the opposite side. That'll give us our S prime. Oops, I counted that. No, that's right. We did that right. So we got that with that and that. There is our rotated triangle 90 degrees about the origin. So 90 degrees is just moving it one more, if you will, one more quadrant left or right, depending on the magnitude. Well, what about 180 degrees, right? We need to try and take, let me blow this picture up. We need to try and take the triangle HUF, H-U-F, and move it 180 degrees, 180. Now, 180 degrees, it can be positive or negative because basically it means a half circle. And so if we start here, we need to end up 2 quadrants away. So we're going to end up in the quadrant up here, quadrant number 1. Okay, so now imagine, let me just try and see if I can rotate, right? If I could rotate this, that's 90, that's 180. Do you see where those points are located? Right, F is closest, and F will always be closest to the y-axis. And so as I rotate them, it's 1 unit away here and 5 units down. So I'm going to go 5 units up and 1 over. It'll be the exact same, just in quadrant number 1, 2 quadrants away. So F prime is there. How far is U? 1, 2, 3 units. So 1, 2, 3 units is going to be U prime. And then we can use this knowledge of slope from both of them. 2 down and 2 over from U. So 2 down and 2 over. Right? If I went 2 this way, I wouldn't have the right triangle. So 2 down and 2 over, which gives me H prime. So it's kind of using this knowledge of slope, trying to just figure out the slope between points, making sure that that slope is consistent. Because remember, that distance, right? This segment, U to H prime, is the same as U to H. They have to be the same distance because that is preserved. All right, let's look at one more. One more. No, I don't have one more. I thought I did. So that's the difference with 180, right? We're not just moving it 1 quadrant, we're actually going to be moving it 2, where when we were working with 90 degrees, we're just moving it 1 quadrant further, all right? Again, make sure you know your notations. The origin is at 0, 0. If you get stuck or you have any questions, please make sure that you reach out. It's really, really, really important. I hope the target practice went well today. Have a great weekend, and until next time, stay safe.